The artificial intelligence boom is driving global demand for advanced chips, and that makes Taiwan a crucial link in the tech supply chain. But as we know, the semiconductor industry has a voracious energy appetite, which means if Taiwan's power supplies can't keep up with what the industry needs, the ripples will be felt across the globe. So how can Taiwan feed the fast-growing chip sector and in turn keep the wheels turning on the world's industries which rely on them? And for this, we're joined by Andrei Covatariu, co-founder of ECERA, an expert network focusing on sustainability policy insight, and Tsai Ying Lu, the director of energy resilience at DSET, the Taiwan-based think tank focusing on democracy, society, and emerging technology. Tsai Ying, we know that Taiwan Power Company has proposed the direct transmission plan for tech and industrial parks. Can you explain what this is and what they're hoping to achieve by this?
Yeah, so this plan is for supporting the need for our science parks directly, especially for their green electricity need. So right now we have the plan for interconnecting our offshore wind parks, which normally are located in the northern region of Taiwan, in the territorial waters. And then the plan is to interconnect all these parks and directly into supports the substation and on land, and also support the science parks technological electricity needs for these green electricity. So this is also part of the efforts about how to diversify the power grid right now. So this is like dividing the power into different usage areas, for one for industry and one for residential. So this is also a way to decrease the possibility of any interruptions that cause regional power outage as well.
Right. Andrei, globally, the biggest tech companies are committed to eventually using 100% renewables in their operations, and that should filter down to supply chains also. But how realistic is this really, given the fact that we're already having enough trouble trying to generate enough power for what we need to use right now, as opposed to it all coming from renewable energy?
It is a massive challenge, and operators, data center operators are aware of that, and for that reason, they're also able to pay a premium for securing as much as possible green generation. And that is because we are seeing this second wave, if you want, of data center expansion driven by AI. And for that reason, electricity plays a huge role in this development of these new data center facilities. That's the reason why operators are queuing everywhere to find capacity and to find clean generation. We are seeing that in North America, we are seeing that in Europe, and of course we are seeing that in Asia, because there's a competition between operators from different countries to do that. But to secure that electricity, they need basically two factors, two elements. One is the clean generation that needs to be timely developed, but at the same time, they do need the grid. They do need the networks in order to transmit or to distribute that electricity from generation to their consumption point, which once again, it's a global issue. Electricity networks are having some big challenges everywhere. So regulators and policymakers need to look at both generation and transmission networks.
All right. So in relation to that, can you explain the concept of liberalized energy supply, Andrei?
Liberalization or free markets can only help parts of the value chain. So when it comes to grids are by definition, the transmission grids or distribution grids are by definition natural monopolies, in the sense that they don't have competition. They're typically, it's only one operator that operates, that has the control of a grid, of a geographical region, and the regulation simulates basically a competition, because the profits and the costs are regulated by this national regulator. When it comes to liberalizing or freeing the market, we can see the benefits, especially when it comes to what Europe has achieved over the last few years, especially on the generation and the retail side. Having a competition on the wholesale market, basically on the generation side, leads to the best prices or the best generators to stay in that market and to serve serve that market. And implicitly, that drives prices down, which will eventually help and will also basically deliver on the reliability of service and the affordability for the end users. But once again, free markets or liberalizing can only help the wholesale and the retail markets. When it comes to grids, that is a state-led decision. That is in regulators' hands on how to do and how to regulate, operate that.
Right, Tsai Ying.
Yeah, just totally agree with Andrei just said. So liberalization in the transmission and distribution sector will only solve part of the problems, not all. And then especially for Taiwan's case, Taiwan has all these data centers as well, and we have more to come to expect. But these are most age scale centers. So this means it's not hyperscale centers that require a lot of energy and also the water to sustain but all these little like edge scale data centers, they are all distributed in different areas. So how do we provide or how does our grid to support these distributed data centers is also very important for Taiwan to overcome the challenge of transmission as well. So instead of thinking of the liberalization of the resale, the wholesale markets or the generation market, I think the transmission and also the current efforts to diversify and also to make the power grid more distributed to support these edge centers are more critical for Taiwan.
Right. You know, you can't talk about Taiwan without talking about one of its biggest industries, and that's the semiconductor industry. So let me give some context here. Taiwan's semiconductor industry is a substantial part of the country's electronics sector, which is a major energy consumer. It accounts for nearly a quarter of the national total consumption. Now, according to Greenpeace, global electricity consumption from AI chip making soared 350% in 2024. That was compared to the previous year. And this, as the Ministry of Economic Affairs projects that the energy demand for AI technologies will increase eightfold from 2023 to 2028. That's a troubling prospect. So, Tsai Ying, large corporations at the moment get priority in procuring green power, but the current renewable generation capabilities in the power grid in Taiwan is unlikely to keep up with the kind of demand we're seeing and the projections we just heard. So what solutions are the energy suppliers looking at, and in turn Taiwan's government?
So two parts. So one, based on our simulation on the next decade, how Taiwan's power system can support the demand for these, especially these energy-intensive industries, like semiconductors. Based on our recent simulation that published early this year, we saw that in the next decade, that regarding the amount, this is actually sufficient. It will be sufficient for Power company and so the electricity system to support the growing demand, like the graph just indicated, in the next 10 years. But in terms of the green electricity, right now the Taiwanese government and also NGOs and also think tanks, they are all promoting that maybe all these energy-intensive industry, they have to also build their own green electricity facilities and to generate the renewables for themselves. For example, one of the biggest electronic suppliers in Taiwan, they actually have the rooftop solar panels to be built on their fabs. So how do we have more players and also the major industrial leaders to join this line? It is very critical for Taiwan to support not only the renewable transition goal, but also to support its industrial growth as well.
Right. So, Andrei, how are those decision makers looking at now the growth of these data centers and these power-hungry industries? And how is there a concerted effort? Like we see big tech companies saying that they might want to build their own facilities, but is there a bigger plan in place, or is it mostly ad hoc?
I would say that at the moment it's mostly a race, and these developers are looking for the best geographies, the best states, the best destinations for this kind of hyperscale data centers, and they're trying to secure those investments as fast as possible. That's the reason why we are also seeing some contracts, some important contracts actually being signed with the Middle East countries that can provide at least partially green energy, but reliable energy and a fast connection to the grid. So that is important for developers worldwide. When it comes to policymakers, of course, generation is a big concern, and we have discussed about that. Grid is a major, let's say, concern on how to accommodate this consumption that has a very high spatial concentration, so they consume a lot in a very small geographical topological area. But at the same time, increasingly so, I would say operators and policymakers are also looking at the demand. So how the demand of data centers will become more efficient, how to come up with different metrics that would incentivize the sector, not only one specific operator, to become more efficient and to reduce its consumption, both on the electricity and the water side. Volume, and that is important. Estimations when it comes to data center consumption for 2030 and beyond vary significantly, because some experts, and I tend to agree with them, are also betting on a more efficient use of AI. So the utility that derives from data center operations will probably become more and more efficient as we go ahead. There was a similar concern in the 90s with the WWW wave, but nevertheless, those increased or very high energy consumption didn't materialize. So hopes are also put in the idea that demand will become more efficient when it comes to data center.
Tsai Ying, Andrei mentioned geography, and we're seeing what we're seeing here is some of Taiwan's biggest semiconductor companies setting up operations in other countries. Is that seen as somewhat of a solution to make sure that operations continue for energy resilience, or is that just good business?
Okay, yeah, so I would say that TSMC's current expansion plan for advanced chips production that still remains in Taiwan. So, and their overseas projects are mostly legacy chips production or only little glamour or advanced chips. So I think the challenges for Taiwan remains the same. And I would not say their overseas project will alleviate the situation, but I do see some opportunities based on these current expansion of advanced chips fabs in Taiwan. The example of this is that we see that TSMC has just signed the biggest power procurements with the Ørsted, the biggest offshore wind developer in Taiwan, that they actually secure the 20 years contracts of their power supply from these offshore wind farms in recently. So I would say this kind of trend that TSMC expanding also to supply not only for their fabs, but also for their suppliers' electricity need, especially green electricity need, would push forward Taiwan's renewable transition in general as well. So I would say this is definitely an opportunity for Taiwan to continue this road.
So Andrei, if we're just about running out of time here, but if I wanted you to look into your crystal ball there, and as we're seeing troublingly the world getting more and more unstable and all these geopolitical issues arising. You mentioned the Middle East earlier. How do you see energy or energy resilience evolving, especially in the areas that you're looking at?
No, I think that the definition of energy security has changed significantly over the last 3 years, even more so, but over the last 10 or 15 years. We have transitioned from relying only on fossil fuels and the export-import of fossil fuels to decentralized, clean, variable generation. And that plays a huge role when it comes to energy security. Although securing critical raw materials and clean technology is also, holds significant challenges when it comes to security and energy security and trade security. But now we are seeing more and more factors that are feeding in or factoring in this definition, like the hybrid war and various geoeconomic issues that we are seeing all around the world. So it is becoming more and more complicated, that's for sure. In theory, energy security in 2050 will be less tense because we will have more local generation. But the road from today until 2050, it's still challenging and will remain challenging in the years to come, unfortunately.
And Tsai Ying, with the developments in Iran and what we've seen in the Middle East and the fact that Taiwan gets a large part of its energy from Qatar, is there any backup plan for Taiwan at the moment if this, which is likely to happen, this instability continues for the long term? And what would your suggestion be that Taiwan should be doing right now to safeguard itself so that it can have that supply of energy that it needs?
So I would definitely say that the current efforts in diversifying all these imported sources, that is one thing that Taiwanese government should continue to do. Another thing is that the diversifying, also distributing power grid enhancements projects that's still facing a lot of challenges, not just about the social consensus about how many substations that need to be built, near their homelands, or also there is some discussion in the legislative yuan that there are budget cuts and everything. These are all challenges that the Taiwanese government need to overcome to secure its renewable transitions in the long way, and to secure Taiwan's energy security and also enhance Taiwan's energy resilience in the long term.
We would like to hear your thoughts. Is the tech industry going to drain all our energy, or can we find a sustainable path through the AI boom? Let us know in the comments, and click the video beside me to learn more about how countries are managing their energy upheavals in this time of global instability. Don't forget to subscribe and hit the bell for more stories on tech and business from Taiwan.